Okay. What we have seen last lecture, we have started with the sequential statements, right? So we have seen different sequential statements that can be used in VHDL programming, and today also we will continue with the remaining part of the sequential statements, and then we will start with the concurrent statements. So uh, we have studied up till now, we have studied different types of or different sequential statement that can be used in a VHDL programming, such as case, then loop statement, then exit statement, right? Then whatever that comes under the process, everything is sequential. So we have up till now we have studied the different statements. Next statement we have studied, then while loop, for loop, assertion statement, then null statement, case statement, if statement, then signal assignment, variable assignment. So this is what up till now we have studied. Now we will move towards the remaining part of this point, and that is sequential statement. And now we will start our discussion with the remaining part of that. And the next statement comes, that is wait statement. Again, I will repeat. We are we are still studying a part of sequential statement only. Okay, and now in later session or in just within a few minutes we will start our discussion with the concurrent statement. Okay, but still up till now we are still in a sequential statement, or we are discussing that point only. Now we will discuss the wait statement. Now similarly, the exit statement causes a simulator to suspend execution of a process, to suspend execution of a process, statement, or a subprogram until some condition are met. Right? What exit statement causes? It suspends the execution of process or statement until and unless some conditions are met. The object being waited upon should be a signal. So actually the conditions you can give a arrival of any particular event or signal. So that will be the condition. Now this wait statement, what it does actually, this wait statement, right, it will hold a particular line, and it will wait on the same line until and unless some new event will occur, right? Particularly this wait statement, sorry, here should be a wait statement, not what we can say exit statement. Here should be a wait statement. So this wait statement, what it does, this causes a simulator to suspend the current execution of a process statement or subprogram, and it will wait for certain condition to happen, it will wait for certain conditions to meet, and then it will proceed with the remaining program. As the name indicates, wait म्हणजे काय, थांब, means it will hold the program execution on a particular line, and it will wait for certain condition or certain event to happen, and then it will start executing the next program or the remaining program. So this is simple use of wait statement. It will hold the, or it will suspend the execution, means it will suspend means what, the program will not executed further. A program will hold on that same line until and unless some condition will happen or some condition will meet or some event will occur, and then it will start executing the further program. So this is about the wait statement, and its syntax is wait, then on, signal name, signal, until some boolean expression. On signal name means what? Wait on this signal until this boolean expression will satisfy. For time expression, you can even mention a time expression also. Means what? For 20-second wait on this, or for 20-second wait on this signal, and after 20-second you can execute the further part. So this also you can use with the help of wait statement. Now you can go through the example, and you will get how to use that wait statement actually. Wait on a comma b, wait until x is less than 10, wait for 10 microseconds. Means now it will hold or it will suspend the execution, and it will hold on the condition to satisfy whatever the line it will get executed. It will stay on that line only. It will not go to the next line until this condition will meet, and then again it will start executing the further program or the remaining program, right? It will wait on that line and it will suspend the further execution. It will wait on that line, it will check the condition, and then it will start executing the remaining program. So this is how you can use the wait statement. Now next is a procedure call. Next type of sequential statement is a procedure call. Now what do you mean by it? In a behavioral design description, some subprograms provide a convenient way of documenting frequently used functions. As I told you, in some behavioral design description, some subprograms that you require frequently to use in your main design or to use in your program. Now, if you are not following this procedure call statement, then what you're supposed to do is you have to write each and every time that program that you require frequently, and you have to proceed with your design. But with the help of this procedure call, whatever the procedure or whatever the sub programs, right, that are the what we can say, some part of design that you require frequently in the further design or in your next design. So you can simply write this procedure call statement, right? You can call that sub program and simply you can proceed with your design. That means whatever in procedure you are calling that program variable that returns the multiple value and its function, right? That sub program is composed of a sequential statement just like a process, right? This procedure call invokes procedures to be executed in a process. That means whenever you call this procedure, that little part of sub program which is of course of sequential statement that will get executed. That means that little part of sub program or that sequential sub program you need not to write. What you supposed to write? You have to write that procedure call statement. येतंय लक्षात? म्हणजे तुमचा एक सपोज 5 लाईनचा एक सब प्रोग्राम तुम्ही लिहिलेला आहे की जो तुम्हाला इन युअर फर्दर डिझाइन यू रिक्वायर टू यूज. मग तुम्ही प्रत्येक वेळी तो 5 लाईनचा प्रोग्राम लिहित बसणार का? इट इज नॉट पॉसिबल. देन व्हाट इज पॉसिबल इज you can simply write that 5 line small program, okay, store it in maybe a package or a library or configuration, and simply with the help of this procedure call you have to call that subprogram and your job is finished. येतंय लक्षात? म्हणजे तो दरवेळी तुम्हाला सब प्रोग्राम लिहित बसायची गरज नाही. एकदा तुम्ही लिहिलात की त्यानंतर ते तुम्ही तुमच्या पॅकेज मध्ये किंवा व्हॉट यू कॅन से कॉन्फिगरेशन मध्ये तो प्रोग्राम तुम्ही स्टोर करा, अँड वेन एव्हर यू रिक्वायर यू कॅन कॉल इट बाय अ प्रोसिजर कॉल स्टेटमेंट. You can call it by a procedure call statement. Now this subprograms or this procedure call statement has a two types. One is a procedure that returns a multiple value, and second one is a function that returns a single value. So depending upon the requirement, you can use the procedure statement or function statement, right? So this is all about the procedure call statement. Now we will discuss the last type of sequential statement, that is a return statement. Now what this return statement do? The return statement terminates a subprogram. The return statement can only be described within a function or a procedure. It is required in a function body but optional in a procedure body, and its syntax is return some expression. That means whenever you happen to terminate your subprogram, right, means what, whatever the procedure call you have started, जे तुम्ही प्रोसिजर कॉल, तुम्ही ज्या प्रोसिजर कॉलनी जो सब प्रोग्राम तुम्ही कॉल केलेला आहे, एनीवे यू हैव टू फिनिश दैट. नाउ दैट प्रोसिजर कॉल यू हैव टू फिनिश विथ दिस रिटर्न एक्सप्रेशन. बरोबर आहे. दिस प्रोसिजर कॉल you can finish with this return expression. Now this return expression you can include it in the functional body, but it is optional, right? You have to include it in a functional body, but it is optional in a procedure body. You have to include in a functional body, but in a procedure body you may include or you may not include. That depends. म्हणजे लक्षात आले, रिटर्न स्टेटमेंट हे प्रोसिजर कॉलचं एंड स्टेटमेंट आहे. प्रोसिजर कॉल मध्ये आपण काय केलंय, वी हॅव कॉल्ड वन सब प्रोग्राम. रिटर्न स्टेटमेंटने आपण तो प्रोग्राम फिनिश करत आहोत. रिटर्न स्टेटमेंट will terminate that sub program, right? Not only that, whatever the sub program you have called in your design or whatever the sub program you have written in your design, you have to finish with the return statement. तो सब प्रोग्राम तुम्ही मे बी कॉल केलेला असेल किंवा तो तुमच्या डिझाईन मध्ये किंवा कोड मध्ये तो तुम्ही लिहिलेला असेल. एव्हरी सब प्रोग्राम हॅज टू फिनिश विथ द रिटर्न स्टेटमेंट अँड द सिंटॅक्स इज ऑलरेडी मेन्शन्ड इन द slide. So you can see that. So return and followed by the expression means what expression or what value or what variable it has to return to the sub program or it has to return. So this is all about the sequential statement, right? Now we will move towards the next point of our discussion, that is concurrent statement, right? Now as I told you, what do you mean by what is difference between the sequential statement and concurrent statement? Can anyone? See, again I am repeating all these concepts because unless and until if you are clear with this, it's difficult for you to write even a simple VHDL code. That's why you must clear with this difference between the sequential statements, concurrent statements, right? This all logic you have to through it. So can anyone?
Sir, a sequential statement execute simultaneously and
Okay, I guess
no sir, sequential statements execute step by step.
Exactly.
And concurrent statement execute parallelly or simultaneously.
Very right. So that is the basic difference between the sequential and concurrent statement. Sequential statements are executed step by step or one after another, and concurrent statements will get executed simultaneously or parallelly. So these are the some concurrent statements that we are using in a VHDL programming. Now which are those? So first one is a process. So all of you are familiar with this. In behavioral style of modeling, we have to, or we compulsory we have to use this process statement, and of course it is concurrent statement. Then concurrent signal assignment statement, then conditional signal assignment statement, then selected signal assignment statement, then block statement, concurrent procedure call, and concurrent assertion statement. So these are the types of sequential statements that we can use in VHDL programming. Now we will start our discussion now with the first type, that is process statement. Remember now, we are discussing the types of concurrent statement. We have finished with the sequential statement. Now, what this process statement do? A process statement is composed of a set of sequential statements, but process statements are themselves are concurrent statements. Very clear, very clear. Process statement itself is a concurrent statement, but whatever that comes under the process statement, or whatever that comes under that process statement, or whatever that composed by that process statement, that all are the sequential one. म्हणजे प्रोसेस स्टेटमेंट हे स्वतः कॉन्करंट स्टेटमेंट आहे, पण प्रोसेस स्टेटमेंटच्या मध्ये जे स्टेटमेंट्स येतात किंवा प्रोसेस स्टेटमेंट नंतर जे सगळे स्टेटमेंट्स येतात ते सगळे सिक्वेन्शियल स्टेटमेंट असतात. हा खूप महत्वाचा पॉइंट आहे अँड यू हॅव टू रिमेंबर फॉर प्रोग्रामिंग पर्पज. हे तुम्हाला प्रोग्रामिंग साठी लागणार आहे, सो यू हॅव टू रिमेंबर दिस. नाउ ऑल प्रोसेस स्टेटमेंट इन अ डिझाइन एक्झिक्यूट कॉन्करंटली. हे पण मी तुम्हाला सांगितलं की असंच असू शकत नाही की फक्त एकच प्रोसेस स्टेटमेंट एका प्रोग्राम मध्ये असू शकतं, असं काही नाही. देर कॅन बी मोर दॅन वन प्रोसेस स्टेटमेंट. मग ते काय होणार, प्रत्येक प्रोसेस स्टेटमेंट हे सायमल्टेनियसलीच एक्झिक्यूट होणार. बट व्हॉट एव्हर द पार्ट comes under that process statement, every process statement that will get executed sequentially. So you have to remember this part. However, at any given time, only one sequential statement is executed within each process. Very clear again. म्हणजे सपोज तुमच्या प्रोग्राम मध्ये 3 प्रोसेस स्टेटमेंट आहेत, तर ते तिन्ही प्रोसेस स्टेटमेंट सायमल्टेनियसली एक्झिक्यूट होणार. पण त्या प्रत्येक 3 प्रोसेस स्टेटमेंट मध्ये जे सिक्वेन्शियल स्टेटमेंट्स आहेत ते मात्र एका वेळी एकच. Why? Because it is sequential, not concurrent. That will get executed step by step only. But all that process statements, 3 process statements will get executed simultaneously. But the part of process statement will get executed sequentially. So this point we have to remember. The process communicates with the rest of the design by reading or writing values to and from the signal or port that declared outside the process. म्हणजे प्रोसेस स्टेटमेंट कम्युनिकेट करतं कुणाशी, दॅट इज or it can communicate a design by reading or writing values to and from signals or port declared outside the process. म्हणजे जी तुमची एंटिटी तुम्ही डिक्लेअर केलेली आहे, पोर्ट डिक्लेरेशन आपण कशात वापरतो, एंटिटी डिक्लेअर करण्यासाठी, होय का नाही. मग जी तुम्ही एंटिटी डिक्लेअर केलेली आहे त्या एंटिटी मध्ये ज्या तुम्हाला व्हॅल्यू, इनपुट आउटपुट व्हॅल्यू ज्या पास करायच्या आहेत किंवा ज्या डिक्लेअर करायच्या आहेत किंवा रीड राईट करायच्या आहेत, त्यासाठी process statement it is act as a mediator to convey the different value or the rest of the design by either writing or reading it from the signal or to the signal or to the port or from the port. It is all about the process statement. Now what about its syntax? Now process, see this label part you need not to mention all the time. This label part happens if you want to give the label to that process, or simply you can write the process directly, no problem. Now this process, then sensitivity list, then process declaration part, begin, then a list of sequential statement. म्हणजे बघा, process statement च्या खाली begin, after begin, whatever the parts or whatever the code you are writing, all it consists of sequential statement. म्हणजे process sensitivity list, process declaration part, begin means now you are starting the process, and after begin whatever the code you will write that forms the or that contains all the sequential statements, or that code it totally consists of sequential statements. म्हणजे तो कोड हा sequential statements नी बनलेला असणार आहे. After begin whatever the code or whatever the design part you are writing, that total consists of only sequential statements. And of course you have started the process, you have to end the process, right? So this is about the process statement. Now this process declaration part defines objects that are local to the process and can have any of the following items. Mean this process declaration part can have any of the this following items. It may have variable declaration, it may have constant declaration, it may have type declaration, or it can consist subtype declaration, or it can have the subprogram body, it can have a live declaration, or it can have a simple use of any clause, right? So this part comes under the process declaration part, right? Means is this in this process declaration part you can write any of the this, you can write any of this type. That means you can write variable declaration, constant declaration, type declaration, subtype declaration, subprogram body, alive declaration, or simply you can use any particular clause. So this is about the process statement. Now you can go through the example of this process statement type. First architecture, then we have defined the signal, then here we have defined label, but you can define or you cannot define. That depends upon the application. Now the process, these are the process, what we can say, process items. Begin. Now this statement is a sequential statement. This and underscore output, whatever you are finding this line, this is the sequential statement. This is the sequential statement. So in this way, you can use this process statement in your programming. Now, next type of concurrent statement, that is concurrent signal assignment. Concurrent signal assignment statement. Now, what it means? Another form of signal assignment statement is a concurrent signal assignment, which is used outside of process but within an architecture. Means this signal assignment statement you can use outside the process but within the signal, within the architecture. Means before the end of architecture you have to use that. Similar to the sequential signal assignment statement, the after clause is ignored by the synthesizer, right? Now its syntax is target signal will get expression after time expression. Means target signal will get the new value after particular time. So this is the syntax of this concurrent signal assignment statement. So you can go to the example of this concurrent signal assignment statement, right? So these are two different architectures, and this is what in the bottom side box we have actually used this concurrent signal assignment statement, right? So this is about the concurrent signal assignment statement. Means what? Simply whenever you want to allocate a new value to the signal, you have to use this concurrent signal assignment statement. But only difference is you cannot use within the process. You can only have to use outside the process. Within the process, which signal assignment statement you can use? Sequential signal assignment statement. का? प्रोसेस नंतर जे सगळे कोड आहेत ते कसे असतात? सिक्वेन्शियल. म्हणजे प्रोसेस मध्ये जर तुम्हाला सिग्नलची चेंज करायची झाली तर तुम्ही काय वापरणार? सिक्वेन्शियल सिग्नल असाइनमेंट स्टेटमेंट. आणि प्रोसेसच्या नंतर विदिन द आर्किटेक्चर तुम्हाला एखाद्या सिग्नलची व्हॅल्यू चेंज करायची झाली तर तिथे तुम्ही काय वापरणार? कॉन्करंट सिग्नल असाइनमेंट स्टेटमेंट. का? कारण प्रोसेस मध्ये सिक्वेन्शियल आहे. once you have ended with the process, now again there is parallel execution. म्हणजे सिक्वेन्शियल सिग्नल असाइनमेंट आणि कॉन्करंट सिग्नल असाइनमेंट मध्ये फरक येतोय का लक्षात? सिक्वेन्शियल सिग्नल असाइनमेंट हे प्रोसेस मध्ये वापरायचं. का? कारण ते सिक्वेन्शियल आहे. पण तुम्हाला जर का प्रोसेसच्या बाहेर पॅरलली तुम्हाला एखादा सिग्नल असाइन करायचा असेल तर तुम्ही कॉन्करंट सिग्नल असाइनमेंट स्टेटमेंट वापरू शकता. पण ते कुठं? आउटसाइड द प्रोसेस. तुम्ही जर का ते इनसाइड द प्रोसेस घातलं तर ते कसं कन्सिडर होणार? सिक्वेन्शियल स्टेटमेंट. मग त्याचं कॉन्करंटचं मिनिंग काय राहिलं? आपल्याला कॉन्करंट सिग्नल असाइन पाहिजे म्हणून ते नेहमी आउटसाइड द प्रोसेस अँड विदिन द आर्किटेक्चर यू कॅन यूज दॅट. सो दिस इज ऑल अबाउट द कॉन्करंट सिग्नल असाइनमेंट स्टेटमेंट. Same conditional signal assignment statement. Now, what it means? A conditional signal assignment is a concurrent statement and has a one target, but can have more than one expression. Means is the target is a one, but it can have more than one expression. And you can use that with the help of when else condition. That means this target will get now we are looking at the syntax for this. This target will get new expression after this particular time when this condition is happen, else this condition is happen. म्हणजे it just like similar to the concurrent signal assignment. But what is difference? Concurrent signal assignment मध्ये तुम्ही एकच कंडिशन टाकू शकता किंवा एकच इक्वेशन देऊ शकता. पण जर का ते मोर दॅन वन कंडिशन वर डिपेंड ठेवायचं असेल तर त्यासाठी तुम्हाला कंडिशनल सिग्नल असाइनमेंट स्टेटमेंट वापरावं लागणार. राईट, म्हणजे तुम्हाला जर का मोर दॅन वन कंडिशन तिथे टाकायची असेल तर त्यासाठी कंडिशनल सिग्नल असाइनमेंट स्टेटमेंट यू हॅव टू यूज. So you can see this example, very easy example I have mentioned here. You can go through it. Okay. Now next type we will discuss is selected signal assignment statement. Now again, what do you mean by this selected signal assignment statement? A selective signal assignment can have only one target and can have only one with expression. This value is tested for a match in a manner similar to the case statement. This means the selected signal assignment will have also one target and one with expression, but it will behave or it will act as a case statement that we have discussed in a sequential statement part. Right, now the syntax for this same with expression, select, then target expression, target name, when choices expression. म्हणजे जर का तुम्हाला सिग्नल असाइनमेंट स्टेटमेंट यू हॅव टू यूज विथ सम पर्टिक्युलर चॉईस. म्हणजे ते सिग्नल असाइनमेंट स्टेटमेंट जर का तुम्हाला कशावर डिपेंड ठेवायचं असेल तर त्यासाठी हे सिलेक्टेड सिग्नल असाइनमेंट. म्हणजे मागचा जो आपण पार्ट पाहिला कॉन्करंट सिग्नल असाइनमेंट किंवा कंडिशनल सिग्नल असाइनमेंट, हे ते सिग्नल विल गेट अलॉटेड डिपेंडिंग ऑन कंडिशन. But you have to depend that signal or you have to change that signal value with some condition, then you have to use this signal selected signal assignment statement. म्हणजे ती सिग्नलचीच व्हॅल्यू जर का तुम्हाला पर्टिक्युलर कंडिशननी चेंज करायची असेल तर त्यासाठी तुम्हाला हे सिलेक्टेड सिग्नल असाइनमेंट स्टेटमेंट वापरावं लागतं. राईट, यू कॅन यूज सिलेक्टेड सिग्नल असाइनमेंट इन अ प्रोसेस. हे तुम्ही प्रोसेसमध्ये वापरू शकता. But once you have declared in the process, it will sequential. If you are declaring outside the process, then it will be the concurrent. Remember this part. This is the example of the selected signal assignment statement. Right. Then next part is the block statement. So what do you mean by this block statement? Block allows the designer to logically group sections of a concurrent model. Means तुमच्या डिझाईन मध्ये जर का सारे व्हॉट कन्सिडर्ड मॉडेल्स असतील, फॉर एक्झाम्पल खूप सारे प्रोसेस स्टेटमेंट्स असतील. प्रोसेस स्टेटमेंट इज अ कॉन्करंट स्टेटमेंट, राईट. That means whatever that comes under process statement is sequential, but process statement is concurrent statement. मग सपोज तुमच्या प्रोग्राम मध्ये खूप सारे असे प्रोसेस स्टेटमेंट असतील. Each process statement you can consider as a one block. प्रत्येक process statement you can consider as a one block. Now, whenever you have to group a section concurrent model, the sections that are not scheduled to be used in another model. So, for that purpose, you have to use this block statement. That means this block statement allows the designer to logically group sections of a concurrent model. म्हणजे ज्या कॉन्करंट मॉडेलचं किंवा ज्या प्रोसेस स्टेटमेंटचं लॉजिक जर का सेम आहे, ज्या प्रोसेस स्टेटमेंट मॉडेलचं किंवा ज्या प्रोसेस स्टेटमेंट पार्टचं लॉजिक जर का सेम असेल तर अशी अनेक प्रोसेस स्टेटमेंटचा तुम्ही एक ब्लॉक बनवू शकता की ज्याचं लॉजिक सेम आहे. मीन्स लॉजिकली दॅट टू मॅच विथ इच अदर. ज्या डिफरंट प्रोसेस स्टेटमेंटचं लॉजिक सेम आहे त्याला तुम्ही एकत्र करून त्याचा एक ब्लॉक तुम्ही बनवू शकता. दिस इज ऑल अबाउट द ब्लॉक स्टेटमेंट. दिस ब्लॉक्स आर युज्ड टू ऑर्गनाइज अ सेट ऑफ कॉन्करंट स्टेटमेंट्स हायरार्किकली. जे हे ब्लॉक स्टेटमेंट जे आहेत ते अशा अनेक कॉन्करंट स्टेटमेंट जर तुम्ही जो ब्लॉक केलेला आहे किंवा जो एक बॉक्स केलेला आहे तो hierarchically you can represent that. What is syntax for this block statement? Label, then block declaration part, begin, then different concurrent statement. म्हणजे इथे तुम्ही ज्या ज्या प्रोसेस स्टेटमेंटचा तुम्ही ब्लॉक केलेला आहे तो त्या कॉन्करंट स्टेटमेंट मध्ये येणार, बरोबर आहे. बट द कंडिशन इज व्हॉट, इट हॅज टू मॅच विथ इच अदर लॉजिकली. त्यातला त्या ब्लॉक मधला प्रत्येक कॉन्करंट एलिमेंट किंवा कॉन्करंट मॉडेल हे एकमेकाशी लॉजिकली मॅच पाहिजे, तर आणि तरच तुम्ही त्याचा ब्लॉक करू शकता, राईट. A block declarative part defines objects that are local to the block and can have many of the following items. म्हणजे हा जो ब्लॉक डिक्लेरेटिव्ह पार्ट आहे, इट कॅन बी सिग्नल डिक्लेरेशन, इट कॅन बी कॉन्स्टंट डिक्लेरेशन, इट कॅन बी टाइप डिक्लेरेशन, इट कॅन बी सबटाइप डिक्लेरेशन, or it can be subprogram body, it can be alias declaration, it can be use clause, or you can put any simple clause, or lastly it can be any component declaration. म्हणजे त्या ब्लॉक डिक्लेरेटिव्ह पार्ट मध्ये you can include these many things. You can write signal declaration, constant declaration, type declaration, subtype declaration, subprogram body, alias declaration, use any clause or component declaration. बरोबर आहे. These many items you can write at the place of block declarative part, right? So this is about the block statement. Again, you can go through the example that you can able to see. So this is about this block. Now in this C, B1 is a block, then signal, this is a block declarative statement. Begin, after begin you have to write the this actually the concurrent statement. This is a bunch of concurrent statement. Then again after begin you can write this concurrent statement, end block 1, B2 block begin, again concurrent statement, end behavioral model. So in this way you can write a block statement, right? In this way you can write a block statement. Now concurrent procedure call. Next type is concurrent procedure call. We have already discussed the sequential procedure call, बरोबर आहे. Simply the meaning has changed in the context with the concurrent statement. Now what it means, a concurrent procedure call is a procedure call that is executed outside a process, बरोबर आहे. Sequential procedure call कुठे होता, inside the process, but this concurrent procedure call can be executed outside the process. It stands alone in architecture. Concurrent procedure call can have in-out parameters, may have more than one return value. It's considered a statement because it is outside the process. That's why it's considered a single statement, and it is equivalent to a process containing a signal procedure call. Concurrent procedure call is equivalent to the process statement only, with differences it is containing a signal procedure call. म्हणजे sequential procedure call आणि concurrent procedure call मध्ये काय फरक आहे? Sequential procedure call you can write within a process, तर ते sequentially execute होणार आहे. Concurrent procedure call you can write outside the process, or simply have to write outside the process, नाहीतर ते concurrently execute होणार नाही. कायम एक थंब रूल लक्षात ठेवा, प्रोसेस स्टेटमेंट प्रोसेस मध्ये जे जे काय लिहाल ते सगळं सिक्वेन्शियल, प्रोसेसच्या बाहेर जे जे काय लिहाल ते सगळं कॉन्करंट. रिमेंबर दिस थंब रूल फॉर द VHDL programming, right? Now this concurrent process call may have in-out or in-out parameters, may have more than one return value, may considered can be considered as a different statement, and it is equivalent to a process containing a single procedure call. म्हणजे हे kind of process statement सारखंच असतं. This is the example of this concurrent procedure call. Architecture begin, then procedure underscore any a comma b end. Again, you can look at the second example, architecture, then begin, then process, begin, procedure. See, within the procedure, you have written this is a sequential procedure call. But within the architecture, you are defining it is concurrent procedure call, right? So, because we have already discussed, you have to write this procedure call outside a process. प्रोसेसच्या तुम्हाला हे बाहेरच लिहावं लागतं, विदिन प्रोसेस लिहून चालणार नाही. So this is about the concurrent procedure call. Now next type we will discuss is the concurrent assertion statement. Now what do you mean by this concurrent assertion statement? The concurrent assertion statement performs the same section and it is used for the same reason as the sequential assertion statement within a process. म्हणजे हे कशासाठी यूज होतं? दिस कॉन्करंट assertion statement performs the same action and it is used for the same reasons as the sequential assertion statement. म्हणजे आपण जे sequential assertion statement मध्ये शिकलो, सेम कॉन्टेक्स्ट कॉन्करंट assertion statement आहे. This statement is used for the simulation purpose only and will be ignored by the synthesis tool. म्हणजे assertion statement हे फक्त सिम्युलेशन साठी वापरतात. सिंथेसिस मध्ये त्याचं कन्सिडरेशन होत नाही आणि ह्याचं वर्किंग हे सिक्वेन्शियल असर्शन स्टेटमेंट सारखंच असतं, राईट? सिक्वेन्शियल असर्शन स्टेटमेंट सारखंच ह्याचं एक्झिक्युशन होतं आणि हे कशासाठी यूज होतात? फॉर द सिम्युलेशन पर्पज अँड इट इज नॉट कन्सिडर्ड और इट इज सिम्पली इग्नोर्ड बाय द सिंथेसिस टूल. सो this is all about the concurrent statement, right? Up till now we have discussed the concurrent statement. Now in next lecture we will start our discussion with the subprograms, right? Now we will discuss the subprograms. Now VHDL provides two types of subprograms. First is a procedure and second one is a function. म्हणजे subprogram चे दोन type, procedure आणि function, right? So that part we will discuss in next lecture. From next lecture we will start our discussion with the subprogram. Okay. Now if you have any query, you can ask me right now. Whatever we have discussed today regarding that, if you have any query, you can ask to me right now. No queries from your side? कुणाला काही शंका आहे का जे आतापर्यंत शिकवलं? कुणाला काही प्रॉब्लेम, शंका, डाउट? You can ask me, no problem. See, always I am telling, don't hesitate to ask the doubt. Okay, then I will assume you are through with this. Okay, now in next lecture we will start our discussion with this subprogram part.